Hello everyone, welcome to our presentation. Today we're going to explore the fascinating world of elementary shapes. The title of our talk is Understanding Elementary Shapes. We'll briefly look at what basic shapes are, why they matter, and how they form the building blocks of more complex figures. I'm excited to share this journey with you, so let's get started. Let's take a look at the contents of this presentation. We will start with measuring line segments, which is fundamental in understanding lengths and distances. Next, we will explore the importance of using a divider in measurement, as it helps us get accurate results. Moving on, we'll discuss the disadvantages of relying solely on observation for measurement, highlighting why tools are essential. Then, we will talk about angles, specifically right and straight angles, and why they are important in geometric constructions. After that, we will cover straight angles and complete angles, which are key concepts in understanding how angles work. We will also classify quadrilaterals, helping us distinguish different four-sided figures. Following that, we'll look into measuring angles, an important skill in geometry. Next, we'll examine the different types of triangles, which are the building blocks of many geometric figures. Finally, we'll delve into polygons, which are shapes with many sides. This overall content provides a comprehensive overview of fundamental geometric concepts, all of which are interconnected and essential for a solid understanding of geometry. Let's talk about measuring line segments. The key idea here is that the length of a line segment is simply the distance between its two endpoints. Now, we can measure these segments in a few different ways, and I'll walk you through the main methods. First, there's comparison by observation. This means just looking at two segments and trying to tell which one is longer. It sounds simple, but keep in mind, this method isn't always accurate, especially if the segments are very close in length. Next, we have comparison by tracing. This involves physically placing one segment on top of another to see which one is longer. While this can be helpful, it can also be quite tricky because aligning the segments perfectly isn't always easy. Finally, the most precise method is using a ruler and a divider. With these tools, we can measure the exact length of a segment. This method is especially important in geometry when accuracy matters a lot. So, understanding these methods helps us measure line segments accurately, which is fundamental for exploring more complex geometric concepts. Now, let's talk about the importance of using a divider in measurement. A graduated ruler and a divider are both useful tools, but they serve slightly different purposes. When comparing lengths of line segments, a divider is especially helpful because it allows us to measure the distance between 2 points directly. You might wonder, why is it better to use a divider rather than a ruler? Well, one key reason is that the thickness of a ruler can sometimes make it difficult to read the exact length, especially for smaller segments. The angle at which we view the ruler also affects our reading, which can introduce errors. In contrast, a divider measures the distance directly between 2 points, making it much more accurate. It doesn't rely on reading off a scale, but instead provides a precise measurement of the space between those points. So, for accurate and reliable measurements, especially when precision matters, using a divider is the better choice. Let's talk about one of the disadvantages of using observation in measurement. When we compare two line segments just by looking at them, especially if their lengths are very close, it becomes quite tricky to determine which one is actually longer. Our eyes can be deceiving, and small differences can go unnoticed or be misjudged. So, relying solely on observation isn't a reliable method when the lengths are nearly the same. This is an important point because it highlights the limitations of measurement by sight, especially when precision is needed. It reminds us that for accurate measurement, especially with similar lengths, we need more precise tools or methods rather than just our eyes. This ties back to the overall theme of understanding the best ways to measure accurately in different scenarios. Let's talk about angles, specifically right and straight angles. An angle is basically the space between two lines or hands that meet at a point. Think of it like when a clock's hand moves from one position to another. Every movement from one position to the next creates an angle, and a full turn of the hand is called one revolution. Now, a right angle is a special kind of angle. It's exactly 1/4 of a full revolution, which means it measures 90 degrees. So, when the clock's minute hand makes a 90-degree turn, that's called a right angle. Since a clock face is divided into 12 digits, and a full revolution of the hand is 360 degrees, we can see how these angles relate. When we divide 360 degrees by 12, we get 30 degrees. That means each hour mark on the clock represents a 30-degree movement. Understanding these angles helps us see how the clock's hands move, and also gives us a foundation for recognizing different types of angles in everyday life. Now let's talk about straight angles and complete angles. A straight angle is essentially half a revolution, which means it measures exactly 180 degrees. When you see an angle that opens up to form a straight line, that's a straight angle. It's called that because it looks like a straight line, and it's a fundamental concept in understanding angles. Moving on to complete angles, these are all about full turns. One complete turn, or one full revolution, is what we call a complete angle. Think of it as spinning around in a circle once. And the key point here is that a complete angle measures 360 degrees, which is a full circle. Connecting these ideas to the overall theme, understanding straight and complete angles helps us grasp how angles relate to rotations and circles. These concepts are foundational in geometry and are used in many applications, from engineering to design. Now let's talk about measuring angles. We use a tool called a protractor to find out how big an angle is in degrees. For example, a right angle measures exactly 90 degrees, and a straight angle measures 180 degrees. Next, let's look at different types of angles. An acute angle is one that's smaller than a right angle, so less than 90 degrees. Think of a sharp, narrow corner. Those are acute angles. Then there are obtuse angles. These are larger than a right angle but less than a straight angle. So they measure somewhere between 90 and 180 degrees. They appear more open or wider. Finally, we have reflex angles. These are even bigger. They measure more than 180 degrees. You can imagine them as angles that wrap around more than half a circle. Understanding these different types helps us describe and measure the angles we see in everyday shapes and designs, which is key to our overall study of geometry. Let's take a closer look at the different types of triangles. First, when we classify triangles based on their angles, we see that if each angle is less than 90 degrees, we call it an acute angled triangle. If one of the angles is exactly 90 degrees, it's a right-angled triangle. And if one angle is greater than 90 degrees, then it's an obtuse angled triangle. These classifications help us understand the shape and properties of the triangles based on their angles. Now moving on to triangles classified by their sides. If all three sides are of different lengths, we call it a scalene triangle. It has no sides of equal length, which makes it quite unique. When any two sides are of equal length, it's called an isosceles triangle. These are quite common and often have interesting symmetry properties. Finally, if all three sides are equal, we refer to it as an equilateral triangle. Not only are all sides equal, but all angles are equal as well, each measuring 60 degrees. To sum up, triangles can be categorized both by their angles and their side lengths. This classification is fundamental because it helps us understand their properties and how they relate to other shapes. Recognizing these key differences is essential as we explore more complex geometric concepts. Now let's look at how polygons are named based on their number of sides. As you can see in this table, a shape with 3 sides is called a triangle. When a polygon has 4 sides, it's known as a quadrilateral. Moving on, a 5-sided polygon is called a pentagon, which you might be familiar with from architecture or design. For 6 sides, we call it a hexagon, a shape often seen in honeycombs. And then there's the octagon, which has 8 sides. This one is well known because of stop signs. What's really important here is that the names of these polygons are directly related to how many sides they have. This pattern helps us identify and categorize these shapes easily. Throughout this presentation, understanding these names will help you describe and analyze various geometric shapes more confidently. Remember, the key point is that the name of a polygon is based on its number of sides, and this nomming system is quite systematic and intuitive once you get the hang of it. Let's take a closer look at how quadrilaterals are classified based on their properties. As you can see in the table, the first category is a trapezium, which has just one pair of parallel sides. Moving on, if a quadrilateral has two pairs of parallel sides, we call it a parallelogram. Now, within parallelograms, we have some special types. For example, a rectangle is a parallelogram with 4 right angles, making it a very particular kind of parallelogram. Then there's the rhombus, which is a parallelogram with all sides of equal length. And finally, when we combine those properties, having all sides equal and all angles right angles, we get a square. It's really the most specific and symmetrical of all these shapes. Overall, this classification helps us understand the relationships between different quadrilaterals based on their properties. Recognizing these key features allows us to identify and distinguish various shapes quickly and accurately. This classification connects directly to the overall theme of understanding geometric properties and how they define different figures.